Okay, in this short demonstration we're going to take a look at some of the important properties inside the grade node. This is the most commonly used color correction tool, particularly when we're looking to adjust the tonal range of the whole image rather than the individual frequencies, such as shadows, midtones and highlights, which we would generally use a different node to do that. And in another demonstration we will take a look at how we can do that and actually access the individual frequencies. But in this exercise we'll generally stick to the full range of the image. So you can see that I've got a composition open already, or should I say a script open, which is essentially a test bed with this gradient here, which is going to enable us to see the characteristics of the grade node and how they affect this image. So I've got this. There's my grade node, and I've also got this sampler node, which I'll just set that to 0 because I've actually been doing some stuff on this already, and just reset that. So this sampler is basically giving us like a histogram. We can look at the individual channels separately, but if we select all of these, we basically see the whole image, and we won't need to see the individual channels for what we're doing in this particular exercise. So we're going to start by taking a look at the black point. So essentially what we would use the black point for would be to pinpoint the darkest pixels of the image, and we would use this often for color matching, so that any composite that we were putting in on top of another image, for example a background, it would basically have the same black points, so it would have the same sort of initial contrast points to any other image that would be in the composition. So when we set the black point, and we would typically set that to the darkest pixel of the image, any pixels of this value are then set to 0, so in other words the colour is turned pure black. So typically, like I've said, we would use this to sample the darkest pixels in the viewer. Okay, so what I'm going to do is I'm going to set a value in the black point properties to 0.2. You can see that we immediately saw a change in the image, as basically 0 position 0.2 was then set to black, which essentially moved the black point across. If we now sample the current frame, we can see how that relates in this histogram. So here's 0.2, which would originally have been somewhere around about here, wouldn't it? And now that's been pulled down to a value of 0. So 0.2, which would have been a dark grey before, has now been clipped to black. And all the values that were less than that are also black, and then the values that are higher or brighter than that value then incrementally increase from that position rather than from the starting position. So let's make a slight adjustment to this. Let's set this black point, rather than to 0.2, let's set it to negative 0.2 and resample again. And we can see a difference. So essentially what's happened now is negative 0.2 has been clipped down to 0. And you can see that effectively the effect of that is that we now have no black images. We have no black pixels within this image. It starts at this negative value of 0.0, and then everything increments increasingly from that particular point. Just wanted to mention that that sometimes it's difficult to actually see the darkest areas of the image. I will actually just set that back to 0 and then just reset this. Sometimes it's difficult to actually see the values, and sometimes what you might want to do is you might just want to gain down in the viewer, and that just allows you to see the darker pixels of the image more accurately, and that's a good way of actually finding the areas of the image that are darkest. And once you've done that, just click on that little highlighted little highlighted Y, and it will reset the gain back to the default value. Okay, so the white point, it's the mirror opposite of the black point essentially. It allows you to sample usually the lightest pixels within the image, and what would happen then is that any pixels of this value would then be set to 1, so pure white, and anything less than that would obviously be incrementing down. So again, we would typically use this to sample the brightest pixels in the viewer and match a foreground element to a background element in that way. So let me set the white point to 0.8 and then resample. So now we're actually looking at the top of the histogram. So we're looking at the values from 1 and down. we may just need to stretch this out a little bit so we can actually see the effect of that. So we can see now that the value of 1 has been clipped back to 0.8, which means that these areas that were these areas, this is the area now that we're defining as white, and anything beyond that is also white, and the grayscale values increment down from this point, from 0.8 down, rather than from a value of 1. So if we set this value to say 1.2 and resample again, so 1.2 now becomes the new value for white, and all the values above are then scaled down. So I'll just reset that back to 0 and resample. Made a mistake there. We're resetting the white point. That needs to be set back to 1, not to 0. And again, to find the brightest parts of the image, sometimes we need to just increase the gain in order to actually establish that. So let's move on and take a look at the next one down, which is the lift. Essentially, when we make changes to the lift, any pixels that are black are set to the color that we set in this. So we would often use this to match the tonal range of one clip with that of another. So just to demonstrate how this would work, we'll set this again, this value to 0.2, and we'll resample our image. Now this is slightly different to what we just saw with the black point. You can see that what's actually happened here is that it's pushed the values up in the dark areas. But the bright areas are completely unaffected by this. So all that effect has done there by increasing the lift has just basically brightened up the values in the darkest areas. It hasn't raised the brightest areas at all. We'll be looking at the offset shortly, and we'll look at the subtle difference between the offset and the lift when we get to that point. But for now, we'll reset that back to 0, and we'll reset the histogram. Okay, so if we now take a look at the gain, this is a very simple scaling property. Essentially, what it does is it multiplies the result of the grade node by whatever factor we set. So at the moment, it's multiplying by 1, so it has no effect. So if I set this gain to say 1.2 and then we sample our histogram, we can see the effect of that. So if we take a look down here, all the values are scaled up. So the dark values have actually scaled up beyond 1, up into these higher values, so they've actually gone beyond the dynamic range. And the bright values have actually scaled up as well. So the white is actually referencing 0.2, and the darkest values are actually extending beyond 1 to 1.2. So the whole thing, the whole image is scaled up on the brightest and the darkest areas of the histogram. So again, we'll just reset this back to 1 and reset that. And then we'll take a look now at the multiply. So let's just take a look at this. Let's change the multiply to 1.2, which we did before, and reset that, resample it. And if we take a look, identical. So gain and multiply are mathematically identical. In the industry, you hear both. And the terms are interchangeable. You just hear both terms, really, depending on what school the people that you're speaking to came from, essentially. So gain and multiply are effectively exactly the same thing in terms of color shifts. So let me set that back to 1 and reset the histogram, and we'll take a look at the offset now. This is the one that I wanted to point out in relation to the lift, because the offset actually it offsets the result of the grade node. So essentially, offsetting is to add a fixed value to the result, which effectively lightens the whole image. But you could also add a negative value into the result, which would darken the image. So if I set the offset to 0.2 and then we sample that. You can see that it's added a constant 0.2 to every code value in the image. So the blacks went up to 1.2 and the whites also went up as well. So they've gone up to 0.2. So effectively what's happened is that the whole thing has been offset upwards. So even though that might look similar to the lift, it's actually different. So we can see here, if we just take a look by comparison, is that our darkest areas have gone up to 0.2, and our darkest areas have actually gone up to 1.2. So if we put exactly the same value back into the lift and we look at the histogram by comparison, we can see again that the lift has gone up to 0.2 in the darks, but the brights are left at value of 1. So they have not. So there isn't an offsetting, which would basically mean that this entire bar would be lifted by 0.2. It's actually just lifted the dark areas. That's what the lift does. Whereas the offset lifts the dark and the bright values simultaneously. So I'll just reset that back to 0 and reset our histogram. And the final property in this run is the gamma. And effectively what this does, this applies a constant gamma value to the result of the grade node. So this lightens or darkens the midtones and effectively clamps the black and the white values. So the result of this is that the darkest and the lightest pixels sort of lessen the more we move away from the center. But the main changes are within the midtones, the center, and gamma is an interchangeable word for midtones. So to demonstrate this, if we just set the value of the gamma to 0.5 and then we resample, we'll see something a little bit different. I guess the most obvious thing is the curve. So effectively the midtones are pulled down, which darkens the image. If we increase the gamma to 2, which is taking it by the same proportion in the opposite direction, we can see now that the gamma curve is the opposite, which brightens the image, so we can see the midtones are being pulled up. But again, our brightest values are clamped at 1, our darkest values are clamped at 0, and the relative increment there is in the midtones. Okay, so this might seem a little bit counterproductive, but I have done this on purpose. I want to come now to the top of the list and actually look at the channels. We can effectively use these channels to basically select the individual components of the image. In other words, the red, the green, or the blue channel of the image, and also the alpha channel if that's set. In this particular case, it isn't set. I don't necessarily need to demonstrate these principles. So, for example, if I disable the red channel and then I sample my histogram, we can see the result of this. We can see that the gamma adjustment is now only applied to the blue and the green channels. By basically disabling it, the red channel is back at its linear state. So let's turn the red channel back on and turn the green and the blue channel off and resample. So now we can see the green and the blue channel are linear, and the effect is only applied to the red, and we can see the effect of that in the viewer. So again, I'll just come back down here, turn all 3 channels back on and resample, and we're back to the gamma curve affecting all 3 channels of the image. So this is a great way of actually increasing the gamma, and a great way of showing you how these channel selection boxes affect the distribution of any one of these properties inside. So far we've looked at all of these properties, and any one of those properties would be affected by the selection of or the deselection of an individual channel. So it really doesn't matter where it is. So for example, if I just set that gamma back, and again I lift my image again, if I turn the red channel off and set that, you can see that lift is only being applied to the blue and green channel, and the red channel's left alone. Okay, I'll just reset that and resample. So on this theme, let's just take a look at these colour boxes. Effectively what these allow us to do, is they allow us to access the individual channels and make commensurate adjustments to the individual channels rather than this kind of all or nothing option up here. So effectively we could apply different gamma curves to different images or different channels within the image. So not necessarily turning a gamma adjustment off on individual channels, but having actually slightly different variations on different channels. And this is essentially how we would finesse a grade. So to demonstrate this, I'm just going to control click on my gamma so that we can actually see the and I'm just going to set this, doesn't really matter where I set it, but now obviously we can see that I've got access in the gamma to the red, the green and the blue channels. So let's set the value of the green up to say 1.5 and the blue channel to say 0.8. So we've created that adjustment in the gamma, and we'll come up here now and we'll resample, and we can see straight away now that we've got a kind of a darkening gamma curve on the blue channel and an increasing gamma curve on the green channel, whereas we haven't affected the red channel, so that's still staying linear. There's no curve being applied to that. And again, even though we've just demonstrated that using the gamma adjustment, I'll just reset all those back to 1 and then resample. So even though we've made that adjustment just to the gamma, again, this could apply equally to any one of the properties. You can see there the gain exactly the same. Again, I'm working in Nuke 8, so I keep forgetting. There's the gain, and you can see I've got exactly the same controls. I can make all the same controls here. You can see there that this will have there'll be an adjustment now affecting the gain on all three of those channels, so they'll all be different. Okay, I just set all those back and resample the histogram. Okay, we've got these options down here called black clamp and white clamp. When the black clamp is enabled, any output values that are lower than 0 are set to 0, and the white clamp sets any output values that are higher than 1 to 1. So by default the black clamp is enabled and the white clamp is not. We need to explore a little bit why this is. So to do that, I'm just going to increase the gain to say 1.2 and resample. So the values in the black and white are both being scaled up by 1.2. You can see here that it's not easy to see within this limited space, but basically the values have gone up. They've gone up by 0.2 on both sides. Now if we enable the white clamp and resample, can you see how all the bright values above 1 were clipped off? Now, with the exception of mattes, we would never want this to happen, because essentially as we do this we lose bit depth. This is what we know as basically clipping our bit depth, and this is where we lose our data, our clarity of image, and the dynamic range within the image. So this is what would happen if our white clamp was enabled. So by and large we leave that disabled. Okay, so let's take a look at why the black clamp is enabled by default. So what we're going to do is we're just going to get our lift property, and we're going to set this, we're going to reduce this quite dramatically. So we'll come down to 0.2, and I'm going to turn this off, and then I'm going to sample. And you can see that we now have black values going below 0, which again we would never want to happen. And certainly never with mattes. So this always needs to be enabled, and I'll just set these. Oops! I'll just set these values back to their defaults and resample the image. Okay. So hopefully that's given you a little bit of an insight using the sampler node here, a little bit of an insight into how these individual points are affecting the linear nature of the values of the image. Okay, so we'll just give a little bit of context to this. I'm just going to shut off these nodes, and I'm going to bring in an image node, which is this one, and just hook my viewer up to this, and then put a grade node into this pipe. So we'll just add a little bit of context to this by using the color picker tool, the pipette tool, to set the white and the black point to this particular image, and hopefully get a little bit more of a contrast, a little bit better tonal range. So we've looked at these selection tools in another demonstration. I'm just going to start with the white point, and I'm just going to show you a little gotcha on this and a way to address it. So what I'm going to do is I'm going to select a white point, and I'm looking at this area in the sleeve to do that. So I've got my pipette selected. If I just hold down Control and then just move around, you can see how by moving around this range, I'm able to sort of set the new white point. So let's go with that. Now you notice that as you move around, you kind of get this flickering color. That can be quite difficult, and it's essentially caused by Nuke toggling between the selected and the previous color value. One of the ways that we can address that is if we hold down Alt and Control at the same time and then sample. You can see that you don't get anywhere near the same effect, and the reason why is that basically that stops Nuke from sampling the color values as you drag around. So let's just say that I'm making that selection. So I'll settle for that and turn that off to lock it in place, and you can see already that I've got a much brighter image there. Essentially, these colors, which you can see are a sort of a pale blue. But we know them to be white. So effectively what's happened now is that the grade node is now clamping those values to white, and anything brighter than those values across the channels will also be white, which is why we've got a lot more brightness in the image. So we can apply the same principles to the black values, and again I'm just going to come into one of the dark areas of the image. Let's go with some of these dark values in here. And again, I'm just going to hold down Control and Alt as I drag around. You can see that I can move around quite a bit and get some different tonality as I move around here. So I think there's some decent color dark values inside there. So I'll make that my selection and lock that off. So we can see here, if we toggle the grade node on and off now, just by hitting just the D key. While selecting the grade node, you can see there's the without and there's the with option. So you can see the tonal range is so much more dramatically improved just by adjusting the black point and the white point of the image. Okay, and just before I wrap up, I just want to show this because it's a little bit of an aside, but let's just go with the white point. You notice that if I hit this little animation button on this side, I can go to set key, and you'll notice now that all these values go blue, and you'll notice that a keyframe's been added. So effectively, I could set a key at frame 20. I could come back to my first frame and set all these values to 0. And effectively, what will happen now is that the image will lift over time through keyframing. It would help if I changed the right values. So I'll set all these back up. We'll reset this color. So I'll start again with that interesting concept there. So again, I'll come to this point here, set a key, come back down to the first frame, and set these values as I should have set them in the first place. And you can now see, if I just play this out, you can now see that that colour changes over time. So we could use this effectively to create dynamic colour changes caused by lighting conditions, which may be within the live plate, for example. So a great way of actually demonstrating how you not only can actually set a colour, but you can actually make a colour change over time. I'll just delete the keys. Sorry, I'll come to the first frame. I don't want to delete that good key. I'll delete that key. So now everything's set. So this is my value. So I'll set this to default and repick my new white range. Okay, and now we'll move on. We'll look at how we can actually constrain a grain using a mask. So if we actually come into our grade node, we can see that we have this mask port. So let's look at how this might work. So what I'm going to do is I'm just going to add a roto node, just typing O to bring out a roto node. And I'm going to actually add a second grade node in here, and I'm going to use this grade node to create quite a sort of a radical adjustment to the gamma properties. So let's see what I can do on the gamma properties. So we'll take the we'll create a real sort of a real kind of yellow situation there. Now let's say that I only want this to affect the area around the eyes. So what I can do is I can actually bring up my roto node and get my Bezier tool and then just start drawing around the eyes. I'm going for the Batman and Robin look here. Okay, so that's a little bit funky, and I'll just pull out the feather bars just to sort of give myself a little bit of fall off here. Okay, so for the sake of this demonstration, this will be okay. So I want this yellow just to affect the area of the around the eyes. So to do this, I'm going to take my mask pipe and I'm going to patch that into the roto node. And we can now see that that color correction that we applied there using that gamma shift there is limited just to the area around the eyes. Okay, and obviously that's quite radical. If I wanted just to change that, I could use my mix property and just mix that back down and just make it a little bit more subtle. So a very sort of radical example of how to do something there, which I've deliberately made exaggerated just purely and simply so that you can see the effects of this. But nevertheless, you can see how you can use different things like masks or other forms of mats to isolate particular parts of the image in order to apply very specific and very individualized color grades.